Yes, this is 300 plus Academy. Still on the subject matter fractions, but this time around, I haven't talked about fractions in the last lectures and using order of operations. It's about time we look at fractions from the perspective of what problems. We want to look at what problems as it relates to fraction. When dealing with fractions, all that we need, and now we deal with it. We talked about that in the last lectures. But now, when we are dealing with word problems as it has to do with fraction, it's a different thing entirely. But notwithstanding, all we need to do in order to be able to answer questions correctly as far as what problems on fractions and mathematics in general, talking about what we call aesthetic reasoning. Yes, that's what problem does. Aesthetic reasoning. It makes you to be able to think within you and of course come out with quality interpretations and consequently solutions. Once your thinking is right and the interpretations you're giving to the word problems, the questions being posed to you is also right, then definitely your answer is going to be right. You know, for word problems, there is no one formula in particular, but there are steps, there are actionable steps that when taken, we will always get the right answer. So our work is well cut out. We want to think right, and we want to, of course, put out the right interpretations so that we get answers and we're able to answer questions with precision. And one of the first things we must always look out when dealing with word problems is to always look out for punctuations. You see, when you have questions, at the end of every punctuations, the examiner is conveying to you a certain information. So what you do to distill that information is this. At the end of every punctuation, pause and, of course, bring out that parameter, write it down. Then you continue. When you see another punctuation, it means you should pause and try to understand what the examiner wants there. You bring out the figure. So it's a case of the question has been brought out in a theoretical form, in written form, in verbal form. So it is your work to crystallize or to distill it and, you know, bring out figures from there so that you can then solve or work with that. So look out for your punctuations. At the end of every punctuation, full stop, comma, semicolon, what have you, the examiner is trying to convey certain information to you. So you take a pause and you bring out the parameter from that question. Another thing as it relates to fraction is this. In the normal sense of things, you need to understand that we have real value and then we have fractional value. Take for instance, if I have, let's say I have 10 oranges. Let's say I have 10 oranges and that is actual value. But in fractional value, that means 1. Or we say 1 over 1. That is the fractional value for this. Fractional value for this. FV. Fractional value. If I have taken 3 out of this 10, that means I took 3 out of 10. To say 3 out of 10, that is fractional value of what I have taken. But whereas the real value of what I've taken is 3. So what is remaining here, the real value is 7. But in fractional representation, that is 7 out of 10. So you need to acknowledge that, look, there is a real value or real figures to quantities, and then there is a fractional value to whatever quantity we are dealing with. Also, take note, I said total fraction is always 1 or 1 over 1. These are points you need to note. Whenever you have a question that deals with time, you must think per time. You must think 1 hour. If the question is talking in minutes, then you must think what is going to happen in 1 minute. If the question is in seconds, you must think what will happen in 1 second. If the question is in days, you must think what will happen in 1 day. So when you talk about time, you think per unit time. Another thing is, let's say like a bonus point now. What you can do when you have word problems is, if you cannot, really grab what the examiner wants, you can represent things using image or diagrams to try to understand, to have a hold on the question. You can use diagram. All the skills are what I am going to use when we start solving now. Okay, so we can use image, we can use diagrams when we are trying to interpret word problems, as that gives us a more it gives us more control in answering the question. Another thing we can do when everything seems gone and we cannot seem to really know what to do, or when we get to those entangled ends, what we can do is to rephrase the questions using figures that we can connect with, that you as a student can connect with. You can rephrase the questions using values you can connect with. But don't forget, in the process of doing all of this, you still must be time conscious, as it's a computer-based exam that wants to test speed, not just precision. It wants to test speed, precision, and how fast you can do things. So you must be wary of time. So having said this, let's get right into it to answer a question. The first question you see displaying on your screen states that a boy has 800 naira. Then you can see a full stop there. So how are you going to interpret? The question says a boy has 800 naira. I'm going to pause because I can see a punctuation there. That's a full stop. As 800 naira. A boy has 800 naira. Full stop. He spends 160. Then there is another punctuation. So you pause. You bring out the parameters. You interpret again. Spends 160 naira. What fraction of his original money does he have left? So what they want here is fraction left. That's what the question wants. So I've been able to bring out the parameters. I've been able to interpret. Now take note that I said that we always have real value for whatever we are dealing with, and we usually have fractional value. If you look at it, this boy has 800 naira. Now this 800 naira here, it's real value, RV, real value. But in fractional terms, total fraction is always 1 or 1 over 1. So in fraction terms, in fractional value, this means 1. This means 1. In fractional value, this means 1. Spends 160 naira. So what that means is this: if this boy had spent 160 naira, that is real value. But in terms of fraction, it means this boy spent 160 out of 800, and that will mean 160 here is 1, 160 here is 5. So in fractional value, it means this boy had spent 1 over 5. So if you're asking me fraction left is going to be the total fraction that I have, which is 1 over 1, take away the fraction that I had spent. So that is 1 over 5. And when I do this, this should give me, okay, the LCM of this is 5. 1 in 5, 5. 5 times 1, 5. 5 in 5, 1. 1 times 1, 1. So that's going to be 4 over 5. That is the fraction left. So you can see, for me to answer this question speedily, if I were to answer this question, I wouldn't even need to write. I can just look at this because I understand that, look, I have real value and then I have fractional value for something. The boy has 800 naira. That is real value. The fractional representation of that is 1 or 1 over 1. The boy had spent 160 naira. In fraction representation, that means 160 is 1/5. So you're asking me fraction left, not what is left. So fraction left is going to be total fraction that I have, take away the fraction that I had spent, and I got 4/5 as the fraction left. Another way of attempting this question could have been, okay, fraction left could have been, what is left divided by what do I have originally, which is 800 naira. So it means I am left with, since I've spent 160, I am left with 640, because 800 take away 160, that's going to give me 640 naira out of 800. If I reduce this to the lowest term, this is 640 over 800, 0 cancel 0, 16 here 4, 16 here 5, so that is still 4/5. So regardless of the method you are following, all we just need is for you to flow with things and use some of these. Okay, moving on to another question. Which that's question 2. As you can see on your screen, it states a flagpole 6.3 meter long is driven 1.4 meter into the ground. So which means here, let me use the scale here. Let me use image. A flagpole, it means we have a flagpole. Let this be my flagpole. A flagpole which was 6.3 meter long. So which means the length of my flagpole is 6.3 meter. We have in the question, you can see it on your screen. A flagpole is 6.3 meter long. A flagpole 6.3 meter long is driven 1.4 meter into the ground. Then you see a full stop. You have to pause. 6.3 meter long, but was driven into the ground. So that, let this be the ground. Let this be the ground. Okay, it was driven into the ground. What was driven into the ground? The length that was driven into the ground is 1.4 meters. So what that means is from here to here is actually 1.4 meter was inside the ground. Okay, what fraction of the pole is above the ground? So what they're asking me is what fraction of the pole above the ground. I'm not being asked what was above the ground. I was being asked what fraction was above the ground. So, and that still boils down to what I'm saying. 6.3 meter here. This is real value, the length of the pole itself. But the fraction, in fractional terms, that is 1 or 1/1. Now, 1.4 meter was driven into the ground, 1.4 meter. But in fractional term, that means 1.4 meters out of 6.3 meters. So in fraction term, that means 1.4 divided by 6.3. Of course, this should mean 14/63 if we move the decimal point. 7 here is going to be 2. 7 here is going to be 9. So 2/9. That is the fraction that was driven into the what? Ground. Fraction driven into the ground. So fraction above. Fraction above. So which means 1.4 meter represents 2/9. So fraction above. Fraction above ground is going to be 1/1 minus 2/9. 1/1 minus 2/9 will give you 7/9. Look for the LCM and of course get things done. So which means fraction above is 7/9. And I can approach this way as well. If I say fraction above, fraction above ground, what was actually above ground? That is 6.3 take away 1.4. That is going to give me 4.9. So 4.9 out of 6.3 was above the ground. 4.9 out of 6.3 was above the ground. So fraction above is going to be 49/63, and that is going to give me 7/9, which is still the same thing. So the main thing here is, look, when you're dealing mathematics that's talking about what problems, there is always the real value there, and there is the fractional value. Total fraction is always 1 or 1 over 1. Look out for your punctuations. When you don't understand what to do, you can use image or diagrams, as that gives you more control as per how you approach questions. Okay, moving on to the third questions. The questions, as you can see on your screen, state there are 572 students in a mixed school. Then you have a full stop there, so you have to interpret since you're seeing punctuation. So what we have there is very simple. There are 572 students in a mixed school, so it means that number of students, that's 572. That is in real value, but in fractional value, without being told, this is going to mean what? 1 over 1. You don't need to be told. If the total number of students you had was 572, that's real value. In fractional value, that is 1 over 1. 5 over 11 of them are boys. So talking about boys, I wasn't given the real value, no, but I was given the fractional value to mean 5 over 11. 5 over 11. So one of the things you must always do is learn to represent fractional value on one side, real values on one side. So we were told how many girls are there. We're looking at the number of girls. This is it. Number of girls, not the fraction of girls, no, number of girls. So it's very easy. It is either I get the number of boys, then I subtract, I'll get this. So when I look at this, our number of boys there is 5 over 11 of the 572 students. So 11 here 1, 11 here 5, 11 here 2. So that's 52. 52 times 5, that is 260 boys. So if I have 260 boys, then girls should be 572 minus the number of boys I have, 260. So the number of girls I have should be 312. Yes, 312 girls. That's one way to approach this. Another way we could have approached this is for us to decide that, look, I want to get the fraction of girls. The fraction of girls will be the total fraction, take away the fraction of boys. That will be 1 over 1 minus 5 over 11. 1 over 1, take away 5 over 11 is going to give you 6 over 11. So it means the fraction of girls is actually 6 over 11. So number of girls, the real number of girls, okay, let me separate this. The real number of girls is going to be 6 over 11 of the 572. 11 here is 1, 11 here is 52. 52 times 6, that is 312 girls. So it doesn't matter, you can see, it doesn't matter your approach. What matters is your interpretation, distinguish between real values and then fractional values, and then know how you navigate. So that ends that question. Let's take a look at another question. The fourth question, as you can see on your screen, says how much less than 6 is the sum of 2 whole number 3 over 4 and 2 whole number 4 over 5. How much less than 6? How much less than 6 is the sum of 2 whole number 3 over 4? Okay, we have 6. So how much less than 6 is the sum of 2 number 3 over 4 and 2 number 4 over 5? You see, so we must be wary of how we interpret. Some will interpret this way. You'll see some students get their interpretation this way. This is the right interpretation because they said how much less than 6 is the sum of this and this. So which means I must carry out addition first. Even looking or going by things, addition comes before subtraction. So I need to look for the sum of this. If you put things this way, 6 minus 2 number 3 over 4 plus 2 number 4 over 5, you will end up getting the wrong answer. It is going to be wrong because This minus is only subtracting this and not having any effect on this. But this is the right thing to do. So this means 6 over 1 minus 2 times 4, 8. 8 plus 3, 11 over 4. Plus 2 times 5, 10, 14 over 5. So LCM of what is in the bracket, according to board mass, you recall in the first lecture, LCM is 20. Okay, 4 in 25, 5 times 11, 55. 5 in 24, 4 times 14, that is 56. Am I okay? 5 in 24, that's 56. So 55 plus 56. So that's going to be 6 over 1 minus 111 over 20. If I try to solve this, LCM is 20. 1 in 20, 20. 20 times 6, 120. 20, 21, 1 times 111, 111. So my answer is 9 over 20. So the sum of this and this is less than 6 by 9 over 20. These are just sheer interpretation. Okay, moving on to the next question. A notebook has 128 pages. 88 of them have been used. What fraction of the book remain? It still boils down to what we are saying, which means you having to distinguish between real values and fractional values. A notebook has 128 pages. You see, notebook has 128 pages. Notebook has 128 pages. 88 of them have been used. So what has been used here is 88 pages. So here I'm being asked what fraction of the book remains. I'm not being asked what remains. It's a fraction remaining. So I am looking for the fractional form, fraction remaining. That is the question. So I need to understand that this is real value for this. So in fractional value, this means 1 over 1. In fractional value, this means 88 out of 128. 88 out of 128. And if we are to, really deal with this, what can go in this? Okay. 8 here would have given me 11. 8 here, 8 in 128, 8 here 1. Therefore, 18, I guess. Yes. Okay, 128 divided by 8. 8 here 1. Remainder 4. 18, 46. So that's 16. That's 16. So that is 11 over 16. So that the fractional value for the part of the notebook that has been used is 11 over 16. So asking me fraction remaining, that's going to be the total fraction I have, 1 over 1, take away 11 over 16, and that is going to give me 5 over 16. You only need to look for the LCM. The LCM here is 16. 1 is 16, 16, 16 times 1 is 16. 16 is 16, 1 times 11, 11. 16 minus 11, 5. That's 5 over 16. So that's the fraction remaining. I could approach things this way, or I could say what part of the book is remaining. The part of the book remaining is 128, which is what I have. Take away the 88 that has been used, and this is going to give me 40. 40 pages remains. 40 pages remains. So if 40 pages remains, fraction remaining is 40 out of 128 pages. So I try to reduce this to lowest term. 8 here is 5. 8 here is 16. So the fraction of the notebook remaining is 5 over 16. So that ends that. So moving on to the 6th question, we have a scenario here. Says, after spending 2 over 5 of our money, you can see on your screen, after spending 2 over 5 of our money on food, you can see 2 over 5 was the part of the money spent on food, and 1 over 6 on cosmetics. Then we have a comma that is a punctuation, so which means we must take a pause and try to interpret. So after spending 2/5 of our money on food, so I'm going to look at things this way. Okay, food, talking about food, you're spending 2/5 of your money. Let the money in this regard be X. Say, okay, let the money be X. So 2/5 of our money on food. So this is 2/5 of the money on food. So that in real value, it means what you spent on food is 2x/5. But in fraction value, what you spent on food is fraction value, FV, what you spent on food is actually 2/5. Okay. On cosmetics, this person spent 1/6 on cosmetics. This person spent 1/6 of our money. Let the money be X. So in real value, this is going to mean X/6. But in fractional value, 1/6 was spent. 1/6 was spent on cosmetics. So we were then told a woman was left with 1,300. So if the total money, let the money this person has be X, then in fractional value, the total money this person has is 1, or 1/1. You understand? So these are the real values first, and then these are the fractional values. Okay, so I was being asked here, a woman has left 1,300. So what was left? What was left here was 1,300 in real value. But the fractional value, we don't know. We don't know what the fractional value will be. Fractional value of what was left. But we know the real value of what was left, which is 1,300. I was being asked, how much money did she have originally? There are several approaches to this. Now, for someone to be left with 1,300, if we know the fraction left, see what was left, which was 1/3, is actually fraction left. Fraction left times the money she had originally. In this case, 1,300 equals, what is the fraction left? We don't know. But here, the fraction left is very simple. The fraction left should have been 1/1, take away what you have spent on food and what you have spent on cosmetics. So that's 2/5 plus 1/6. Yes, 2/5 plus 1/6. Look at it very well. Fraction left times the money you had originally. See, you were left with 1,300. For you to add that 1,300, that must have been what fraction was left times the money you had. So the fraction left was 1/1, take away this. So this would have given you 2/5 plus 1/6. If you work that out, LCM is 30. 5 in 36, 6 times 2, 12. 6 in 30, 5 times 1, that's 5. So that's going to be 1/1 minus 17/30. 1/1 minus 17/30, which will give you 13/30. 13/30 is the fraction left. So which means 13/30 of the money we had originally of X was 1,300. So if I solve this, I would have been able to get my answer, which the question is, how much money did she have originally? So what I have here is 1,300 times 30 equals to 13x. So x equals to 1,300 times 30 divided by 13, and x here is going to give you 13 here 1, 13 here 100 times 30, that is 3,000 naira. Now there is another way of approaching this question. I could turn this question totally into an algebra looking kind of question, and I would say, okay, what was spent on food? Food. Okay, I would say I could approach this and say, let the money she had originally, let that be X, so that what was spent on food is going to be 2/5 of X, and that's going to be 2x/5. What was spent on cosmetics? That's 1/6 of X, and that's going to be X/6. Then what was left was 1,300. If I had what was left plus what was spent on cosmetics plus what was spent on food, everything should give me the money I had originally, meaning food plus cosmetics plus what I had left should give me the money she had originally. And in this case, that means 2x/5 plus x/6. 2x/5 plus x/6 plus what she had left, which was 3,000. Everything should give me x. That's what it means. So here, this is like 3,000/1. The LCM here is 30. 5 in 30, that's 6. 6 times 2, that is 12x. 6 in 30, that's 5x. Plus 1 in 30, 30 times 3,000, that is 30 times 3,000, that should be oh, okay, sorry, what was left was 1,300. What was left was 1,300. We made a mistake there. 1,300. So 1,300 times 30, that should be 39,000. That should be 39,000. Yes. Yes, 39,000. Everything equals to x. Of course, 30 is going to move here. So what I'm going to have is 12x plus 5x, 17x plus 39,000 equals 30x. 39,000 will now be equal to 30x minus 17x. So 39,000 equals 13x. So therefore, x from here, my x is going to give me 39,000 divided by 13. 13 here 1, 13 here 3. My answer x is 3,000 naira. So the amount of money she had originally going by this is still 3,000. Going this way using real values and fractional values, this gives me 3,000. So that ends that question. So let's have another question similar to this. You can see that displaying on your screen. A woman spent 1/3 of her money at the market, and then you can see a punctuation there. So it means that you can say, okay, at the market, someone had spent 1/3 of her money at the market. So that's like fractional value. So which means what the original amount or the total amount in fraction form is 1/1. So let's say, let the original amount this person had, let that be x, so that this is the fraction value, this is the actual value, so that if this person has spent 1/3 of x at the market, in fraction value this will be x/3. So fraction value here, real value here. So 1/3 of x is going to give you x/3. Okay, let me put that this way. This is in fraction form. So at the market, 1/3 of x, that's going to give x/3. So, and then if you look at the question, continuing further, 1/4 at the chemist. So which means at the chemist, this person spent 1/4 of the money. That's in fraction, but in real value, that's 1/4 of x. So this is going to be x over 4 spent at the chemist shop. Okay, and 1/6 at the electrical shop. So at the electrical shop, 1/6, that's in fraction form. In real value, 1/6 of x. So that is going to be x over 6. Okay, here we had 555 naira left. Okay, what was left was, this cannot, 555 cannot be here because this represents fraction, this represents real value. So what we have here, what was left is 555 naira, but we don't know what that fraction here will represent. So looking at this, if I look at this, the fraction here should be 1/1, take away the sum of 1/3 plus 1/4 plus 1/6. Like you take this fraction, and this fraction together, you subtract it from the original fraction, which is the total fraction. We should be able to get the fraction of what is left. So this is 1/1 minus, if I go to my rough work, 1/3 plus 1/4 plus 1/6, 1/3, LCM of 3, 4, and 6, 3, 4, 6, 2, 3, 2, 3, 2, 3, 1, 3, 3. That should be 12. So that this is 12, and 3 into 4, 4 times 1, 4, 4 into 12, 3, 3 times 1, 3, 6 into 12, 2, 2 times 1, 2. So 1/1 minus 9/12. So this should give you, fraction that is left should give 1/1 minus 9/12 is going to give you 3/12, which invariably means 1/4. That is exactly the fraction that was left. So what this means here is that, if this is what is left and this is exactly what I have, what this means is that if I should say, okay, 555 must have been possible by saying 1/4 of the money we had originally, which was x. So going by this, 4 is going to come here. So 555 times 4 equals to x. Therefore, x equals to 555 times 4. That is 2,220 naira. So that is our answer. That's looking at it in one way. Looking at things in another way, I could decide not to go the way of the fraction value. I could decide to go in the way of the actual value. So what that means is that by the time I had what I spent at the market plus what I spent at the chemist plus what I had at the electrical shop, plus what was left, everything should give me the original amount of money I have, which was actually x. So what did I spend at the market? X/3. What did I spend at the chemist? X/4. What did I spend at the electrical shop? X/6. What did I have left? 555. And how much did I have when I had all this together? It should be my x. This is like over 1. So LCM of 3, 4, and 6 is actually 12. 3 into 12, 4, 4 times x, 4x. 4 into 12, 3, 3 times x, 3x. 6 into 12, 2, 2 times x, 2x. 2x plus 1 into 12, 12. 12 times 1 in 12 is 12. 12 times 555. That is 6660. That's 555 times 12. everything equals to x. So therefore 4, 3, 2, that gives me 9x. This is moving to the other side, plus 6660 equals to 12x. So collecting like terms, 6660 equals to 12x minus 9x. So that's going to give me 3x equals to 6660. Therefore, x equals to 6660 divided by 3, and that's going to give me 2220. That's 2,220 naira. That is the money I have to start with. So that ends that. So the key thing here is this: still going the way of real values and fractional value. Once you're able to distinguish between the two, okay, this is fractional value, this is going to be my real value, total fraction is always 1 or 1 over 1. There is nothing you cannot do once it comes to word problems on fraction. So that ends that. So another question, as you can see displaying on your screen, it talks about one person being able to plot, work on a yarn plot for 5 hours, and another person being able to do that in 4 hours. Of course, looking at a question like this, once I can see timing there, I begin to think per hour, I begin to think per time. Recall that in one of the processes or the skills we can use when dealing with word problems, that I said, once you spot timings in your questions, then what you should begin to think is per hour. So this says Ayuba can owe a yarn plot in 5 hours, and Saliu can owe it in 4 hours. And then the question then goes, what fraction of the plot can each of them owe in 1 hour? That is, what can they do in 1 hour? Of course, this looks somehow, but I think I can then use a diagram here if I want. Okay, since Ayuba can do this in 5 hours, okay, 1, 2, 3, 1 hour, in 1 hour, in 1 hour, in 1 hour, in 1 hour, and then in 1 hour. So 1, 2, 3, 4, 5. If Ayuba is allowed to work just for 1 hour in 1 hour, then it means this person would have only been able to do 1 out of 5. So in 1 hour, Ayuba will do 1 over 5 of the plot. And talking about Saliu, if I follow the same method, since this person can execute this job in 4 hours, 1 hour, 1 hour, 1 hour, 1 hour. So if I allow this person to work for only 1 hour, this person would have only been able to do 1 over 4 of the plot. So that's what the first part of the question said. What fraction of the plot can each of them owe in 1 hour? That ends that. And they said, if they work together, what fraction of the plot will they owe in 1 hour? If they work together, okay, working together, if they were to work together, let me use a diagram still. If they are to work together in 1 hour, what fraction would they have been able to? Let Ayuba start from here. Let Saliu start from here. In 1 hour, Ayuba would have only been able to do 1 over 5 of the plot. 1 over 5 of the plot. And Saliu would only have been able to do in 1 hour, moving in this direction, this moving in this direction, moving downward. Saliu would have only been able to do 1 over 4 of the plot. So working together in 1 hour, that will mean 1 over 5 plus 1 over 4, and that is going to mean LCM is 20, 5 in 24, 4 plus 4 in 25, 5 times 1, 5. That means they would have been able to do 9 over 20 of the plot in 1 hour. Take note, in 1 hour, when they work together, in 1 hour, working together, in 1 hour, they would have been able to achieve 9 over 20 of the plot. Okay, how long will it take them to owe the whole plot working together? How long will it take them to owe the whole plot working together? Now, what that means is that I can decode from here that in 1 hour they would have been able to do this. Now I'm being asked how long. How long means time. To hold the whole plot. To say the whole plot here means, to say the whole plot means one plot or 1 plot or 1/1 plot. That is what that means. So if in 1 hour they were able to do 9/20 of the plot, 1 hour, in 1 hour they were able to do 9/20 of the plots, then I'm being asked how long the timing it will take to take care of 1 plot. So this is what we are just about to deal, this is just what we're about to deal with now. But of course, when you have a question like this and you cannot seem to, have a hold of it, I said you can rephrase. I said you can rephrase things to suit you. Okay, let's say it will take me 2 hours. Let's say it will take me 2 hours to take care of 4 rooms. Then, okay, let's say it will take me 1 hour to take care of, let me make it 2 rooms. I want to rephrase so that I know what to do here. It will take me 1 hour to take care of 2 rooms. How long then will it take me to take care of 10 rooms? If I will take 1 hour to clean up 2 rooms, how long will it take me to clean up 10 rooms? If I take 1 hour to clean up 2 rooms, how many 2 rooms can I get in here? But I've been told, okay, if 1 hour will take 2 rooms, then how many 2 rooms can I get here? That is what? 5. So that means 5 hours. So in other words, I'm more or less saying 10/2. If in 1 hour, now bringing this, I just rephrase to understand what I want to do. If in 1 hour I would have been able to take care of 9/20 of the plot, then how long will it take me to take care of 1 plot? Of course, 1 plot is more than 9/10, just like 10 rooms is more than this. So how many of this can I get here? How many of this can I get here? That is the timing it will take me. So my time here is going to be 1 plot divided by 9/20 of the plot. The same way we had to rephrase here. We had to rephrase 1 hour to take care of 2 rooms. Then how long will it take to take care of 2 rooms? It means if in 1 hour I'll do this, how many 2 rooms can I then get in here? 5. That's going to take me, the timing will now be times 5, since I can get this 5 times in 10 rooms. Also, if in 1 hour I'll do this, then it means how many of this can I get in 1 plot? So this will mean, consequently, this will mean 1 plot takes out plot. 1 times 20/9 hours. So the timing it will take is going to be 20/9 hours, or 2/9 hours. Or we can as well now have to convert, so that the timing here will mean 2 hours. Of course, how do we convert from hours to minutes? That's going to be 2/9 times 60. So 3 here is 3 here is 20. So this will give me 40/3. 40 divided by 3, that's 2. This is going to give me 2 hours. Now I have 2 hours here normally, so 2/9 hours times 60, that's going to give me 40/3. How many 3 can I get in 40? That's 13 minutes. But of course, I'm left with a remainder, which is 1/3. 1/3 minutes. So how do I convert 1/3 minutes to seconds? And I have to multiply by 60 again. So 3 in 60, that is 20. So that if I am not leaving my answer this way or this way, if I don't have that in the option, I know that that means 2 hours, 13 minutes. This will give me 20 seconds. So my answer is actually 2 hours, 13 minutes, 20 seconds. So it depends on the format you have for your answer. That said, now look at this question. You can see it's displaying on your screen again. Look through the question again and look at the plottings. Now I'm going to have to talk more on this question. Under normal exam conditions, this is how you are going to have this question. It should be Ayuba. It should be Ayuba can owe a yam plot. Ayuba can owe a yam plot in 5 hours. In 5 hours. And Saliu can owe it in 1 hour. In 4 hours, sorry, in 4 hours. Normally, they are not going to ask you, as you can see on your screen, what fraction of the plot can each of them owe in 1 hour. That is just like helping you towards the main answer. Nobody is going to ask you that. If they work together, what fraction of the plot will they owe in 1 hour? Nobody will ask you that. What they will just ask you, how long will it take them to owe the whole plot working together? How long will it take them to owe the whole plot working together? That is what you're going to have. This is how the question should look like. So asking you what portion of the plot can each of them owe in 1 hour is like helping you towards the answer, and then asking you if they work together, what can they do in 1 hour is like helping you towards the answer. No, this is what the question should look like. It becomes your own responsibility to know that, look, I should be able to know what Ayuba can perform in 1 hour, what Saliu can do in 1 hour, so that if they don't work together, you take together what each of them can do in 1 hour, so that you know that in 1 hour when they work together, they will be able to perform or take care of 9/20 of the plot. And then you can then say, okay, if in 1 hour they can take care of 9/20 of the plot, then how long will it take them to take care of the whole plot? And then of course from there you take it down here and you get your answer in whatever form that they wanted. So that ends that question. A bit tedious question. So that ends that. So because the last question talks about timing, now let's look at another question that talks about timing, so that you see that once you see timings in a question, in a word problem involving fractions or maths generally, you must always think per unit time. That's if it's in hours, you think 1 hour. If it's in minutes, you think 1 minute. If in seconds, you think 1 second. Now, looking at this question, it says, working independently, Joe can perform a certain task in 6 hours, and Tom can perform it in 7 hours. You can see there is a punctuation right here. So once you see a punctuation, you stop and then you interpret. This says Joe can perform a certain task in 6 hours and Tom can perform it in 7 hours. So what that means is that we have Joe can perform the task in 6 hours, and then Tom can perform the task in 7 hours. Okay, there is a full stop there, and I've interpreted that. But regardless of whatever they want me to calculate, I just want to think 1 hour. So I know that in 1 hour, Joe would have been able to perform the task. Joe will be able to complete will be 1/6 of the task, and then Tom would have only been able to complete 1/7 of the task. That's my interpretation. Now, if Joe and Tom work together at the task for 3 hours, then there is a comma there. Okay, we have Joe and Tom working together at the task for 3 hours. Okay, this is how I am going to think. Okay, I want Joe and Tom to work at the task in 1 hour, so that in 1 hour, that will be 1/6 plus 1/7 of the task, and that should give me LCM of 7 and 6 is 42. 6 in 42, that's 7. 7 times 1, 7. 7 in 42, 6. 6 times 1, 6. So that is 13/42 of the task. So it means that Joe and Tom working together in 1 hour would have been able to do 13/42 of the task. So that if Joe and Tom work together at the task for 3 hours, if in 1 hour they were able to perform 13/42 of the task, in 3 hours, then they will be able to perform 3 times 13/42 of the task, and that will give us 39/42 of the task. Now, if Joe and Tom work together at the task for 3 hours, at which point Joe, so at for 3 hours, Joe and Tom at work, and they perform 39/42 of the task. So the task left. The total task, just like total fraction is always 1 or 1/1, the total task is 1/1. So take away 39/42 of the task. So this will mean LCM is 42. 1 in 42, 42. 42 times 1 is 42. Take away 39. So this is going to give you 3/42. Can 3 go in 42? Okay, 3. Yes, 3 can go. So 3 here 1. 3 in 42, that is 14. So 1/14 of the task was left. At which point Joe leaves. You understand? That 1/14 of the task was left. Now Joe leaves. How many hours will it take Tom to complete the task? So Tom is to perform the task. For Tom now, you want to perform how many hours will it take Tom to complete the task? So we're looking at the timing. It will take Tom to perform 1/14 of the task. But recall that Tom, it will take in 1 hour. Recall that in 1 hour, Tom will perform 1/7 of the task in 1 hour. So this is what I want to deal with now. So when you have something like this, recall that one of the points I gave you is that you can rephrase if you don't know what to do. I will use the same analogy I used in the last question. And let's say it takes 1 hour to clean up 2 rooms. How long will it take me to clean up 10 rooms? If the rooms are of the same size. Of course, if it will take me 1 hour to clean 2 rooms, then how long will it take me to clean 10 rooms? That means how many 2 rooms? I can get these 2 rooms 5 times in the 10 rooms. So which means this is like saying 10/2. How many times can I get 2 in 10? That is 5. So that's 5 hours. So it's the same thing. It's the same approach here. If it will take me 1 hour to do this, then how long will it take me to do this? So just like how many 2 rooms? How many of these 2 rooms do I have in 10 rooms? So how many of this do I have in here? How many of this do I have in here? So the timing here is going to be 1/14 divided by how many of these can I get in here, divided by 1/7. Just like you're saying 10 divided by 2, because 1 hour to take care of 2 rooms. So how many 2 rooms can I get in 10? So 1 hour to take care of 1/7 of the task. So how many of 1/7 of the task can I get inside 1/14 of the task? Of course, this will mean 1/14 times 7/1. So this will give you 1/2 hours. That is my answer, 1/2 hours, because they asked how many hours will it take to complete the task. And for Tom to complete the remaining task, which is 1/14, 1/14, that is 1/2 hours. If you want it in minutes, that is 30 minutes. So it's not very difficult. It's something very direct. Once your thinking and your interpretation is right, take note of your punctuations. When they are talking time, think of in 1 hour per unit time, and then flow with whatever the question is saying. If your thinking and interpretation and your approach is right, then you will always get your answer. I think that answers that on what problems on fraction that involves timing.